Here's an example 3 of transformations of a parent function. Our function for our parent is a square root function. F of x equals the square root of x. And our transformation is a negative, and it's in front of the function. In front. So if we look at our chart, when it's in front of the function, a negative is in front of the function, in front of the square root, we say it's a reflection about the x-axis. And the rule is every y value is going to be the opposite sign. So let's go ahead and describe it. It's a reflection about the x-axis. As a rule, every y number is going to change signs. So let's come down. Every y number will be a negative. So if our g of x equals negative square root of x, and f of x equals the square root of x, we're going to find those 5 order pairs by evaluating the function. So square root of negative 2, negative square root does not exist. Square root of negative 1 also does not exist. Square root of 0, 0. So there's your first value for x. Square root of 1, 1. Square root of 2, approximately 1.4. So if we go and graph that, 0, 0, 1, 1, 2, 1.4. So there is our f of x function, our parent. Now let's do our g of x. So in our rule, nothing is changing on the x's. So we have negative 2, negative 1, 0, 1, and 2. Now our y's. Our y's are going to have negatives. So the negative of nothing is still nothing. The negative of nothing is still nothing. The negative of 0 is 0. The negative of 1 is negative 1. The negative of 1.4 is negative 1.4. So now let's go ahead and graph those. The first order pair is 0, 0. Over 1, down 1. Over 2, down 1.4. So there's our new function for the g of x. Now let's identify the domain and the range. Now domain for our g of x function starts to the right of that number. So we say then x is greater than or equal to 0. I'm just going to do purple here. Y equals 0. Everything below that purple line exists for the red function. So we say that y is less than or equal to 0. And this again is for your g of x function.